so this is video number 1 for lesson 3.2, the graph translation theorem. So our instructions ask us to graph the following functions and write the translation rule for each function. So anytime you're asked to graph a function, the first thing you have to do is determine the parent function. That's going to always be our first step. So as we go through to determine the parent function, let's look at number 1. Y equals the absolute value of x plus 4. My parent function is y equals the absolute value of x. For number 2, y equals x squared minus 1. The parent function is y equals x squared. For number 3, y equals the square root of x plus 3. The parent function is simply y equals the square root of x. So that's my first step, find the parent function. Let's go down to 4, 5, and 6 and do the same thing here. And you can see that I've already written those in. For number 4, y equals the absolute value of x minus 2 is y equals the absolute value of x. For y equals the quantity x plus 3 squared is simply x squared. If we were to expand x plus 3 squared, it would be x plus 3 times x plus 3. We would end up with a quadratic. And y equals the square root of x minus 1 is simply, its parent function is y equals the square root of x. So that's our first step, is to determine the parent function. And its graph. Now when I say its graph, I mean the general shape of the graph. The shape of the graph. So that's why the first section that we did was so very important, because we had to learn what these general shapes would be. So y equals the absolute value of x, I know, is V-shaped. I'll just draw a little V shape over here off to the side. I know that's going to be a V-shaped graph. Y equals x squared is going to be a U-shaped graph. And y equals the square root of x is going to be a curve that's just in that one quadrant there. Okay? All right, let's come down to these. Same thing, y equals the absolute value of x is V-shaped. Y equals x squared is U-shaped. And y equals the square root of x. That curve like that. Okay? All right, so we have done step 1. We determined the parent function and its graph, the shape of the graph. The next thing we have to do is we have to figure out how x and y are changing. Determine the change in x and y. Because we're simply going to take the shape of this graph and we're just going to translate it or slide it. The word translation is another word for a slide. So we are simply taking these parent functions and sliding them on the graph. So we need to determine how are we going to slide them. So we're going to look at the calculator now. All right, so for this first one, we're going to do the absolute value. So that's the math button. Go over to the word number, and absolute value is the first choice. And I'm going to put the absolute value of x. And let's look at that graph. It is indeed a V-shaped graph. Then I'm going to go to y2, and I'm going to once again do absolute value of x. And then that plus 4 is outside of the absolute value sign. And I'm going to graph it, and look at that. It moved the graph up 4 units. It didn't move it left or right at all. It simply moved the graph up 4 units. So determining the change in x and y, the graph moved up 4 units, which affects the y. That doesn't affect the x at all. So my third step, I'm going to go ahead and write my translation rule. where I use a capital T for translation. Nothing happened to the x, so I just leave x by itself. I could put plus 0 if I wanted to as a placeholder, and y, since it went up 4, is plus 4. And my fourth step is to graph it. So I'm going to move up 4 units, 1, 2, 3, 4. This is just a sketch. And I'm going to do my V that's moved up 4 units. Okay. Now I'll tell you, steps 3 and 4 you can switch. If you want to graph it and then write the translation rule, you can do that as well. All right, let's go on to number 2. All right, we know that y equals x squared is a quadratic. It's a U-shaped graph. And so we've already done step 1. We need to determine the change in the x and y. So we're going to go back to the calculator. All right, so I'm going to go ahead and put x squared in and graph it. And it's indeed a U-shaped graph. Then I'm going to go to y2, and I'm going to do x squared minus 1. And let's graph that. And look, it moved that quadratic down 1 unit. So let's write that down 1 unit, which is going to affect the y once again. So I'm going to go ahead and write my translation rule. It's saying I'm going to do nothing to the x, and the y is going down 1 unit. So I'm going to go down 1 unit, and I'm going to draw that quadratic. Let's see if I can get maybe another color so that those graphs, because I've got so much on my paper, can show up a little bit better. There we go. So we wrote that it was down 1 unit, and there was my graph. Sorry, it's getting a little messy. Okay, let's go to number 3. Now, based on numbers 1 and 2, I'm having a feeling that I think I know what's going to happen here. I think that plus 3 is going to make the graph move up 3, which is going to affect the y, which would make my translation rule x, y plus 3, and it would make my graph go up 3, 1, 2, 3, and then just the same shaped graph. And I'll do that in another color. But I'd like to double check this on the calculator. Alright, so let's check and see what this is going to graph. Make sure when you put it in the graphing calculator that that plus 3 is not underneath of the radical. And we'll graph it. The blue one will be the parent, the red will be the translated one. And look at that. Sure enough, it moved up 3 units. Alright, so let's make sure we've got this. So our first step is to determine the parent function and its graph. Our second step is going to be to determine the change in the x and the y. So far, we've only had changes in the y. And then our third step is going to be our translation rule. We want to write that translation rule. And our fourth step is to graph. Now, I'd like to show you, before we move on to numbers 4, 5, and 6, that there is another notation for writing the translation rule, and it's called a subscript. So when you write your translation rule, you can write the capital T and then an ordered pair that shows what the change in the x and the change in the y is. Another way is to write the capital T and then in a subscript, since we didn't change x at all, we just put 0 for the x and 4 for the y. So on this one, our translation rule, we didn't do anything to the x, that's 0. And the y was minus 1, so we just put the minus 1. And because these are kind of written like an ordered pair, that we don't put the parentheses, it's understood that the first one is what's affecting x and the second one is what's affecting y. So this third one is nothing happening to the x and the y is going up 3. So I just wanted to show you that there's two different ways to write those translation rules, either in this ordered pair format or this subscript format. Both of them, though, begin with the capital letter T. All right, so we've got our 4 steps, and we've got our 2 different ways of writing our translation rules. Let's go down to 4, 5, and 6. All right, so let's see what's going to happen to these. So we've already identified the parent function and the shape of the graph, so we need to determine what the change in the x and the y is going to be. So let's move to our calculator. All right, so I've already put y equals the absolute value of x in, and then let's go ahead and put y equals the absolute value of x minus 2. There we go. So let's graph. You see a V, and then the red one, the V moved to the right 2 units. All right, so for this one, it moved to the right 2 units, which I have to say I'm a little surprised. When I saw that minus 2, I thought it would either go down 2 or left 2, but it went to the right 2 units. Now the difference that I notice in numbers 1, 2, and 3, when they went up and down, versus this one going to the right, when I compare number 1 and number 4, here the plus 4 was outside of the absolute value, and here the minus 2 was inside the absolute value. It's the only difference that I notice. And I also then see that this went to the right, even though I would have thought minus would send it to the left. This is what it's telling me is going to happen. So let's write my translation rule. The x, and by the way, this is affecting x because it's to the right. So x plus 2 is going to the right, and nothing happened to the y. So I'm going to move 2 to the right, and I'll sketch my V. Let's use my other color. Sorry about that. Hit my camera there. All right. And then I want to write my translation rule using the subscript, 2 on the x and nothing on the y. Okay. All right, let's go to number 5 and see what happens here. So I've already identified my parent function, and I know the general shape of the graph, so we're going to go ahead and go to the calculator. Okay. So let's see what happens to the graph. This one moved to the left 3 units. Going left 3 units, which affects the x. So for my translation rule, the x is going left, that's x minus 3. Nothing happened to the y. I could also write it using the subscript notation, -3, 0. And I'm going to do the sketch of my graph. It goes left 3 units, 1, 2, 3, and I draw a U-shaped graph. I'm going to use my other color. Alright, well, I'm finding this interesting. When this said plus 3, it went to the left. This said minus 2, it went to the right. It seems to do the opposite of what we're expecting. So let's think about number 6. I'm thinking it would go, well, since it's underneath, it's in the grouping symbol. Each of these had the number inside the grouping symbol, just like this one. So I'm thinking this one is going to go right 1. Let's check the calculator. In my equations, notice the -1 is under the grouping symbol, and I graph it, and sure enough, it moved to the right 1. And we will continue in our next video.